Chemical changes. Learning intention. I will understand how technological devices have changed our understanding of the structure and properties of elements. The technological device of battery was used to discover new elements, including sodium, potassium, strontium, barium, magnesium, and calcium, as electricity was passed through solutions, and we discovered that these elements were hiding inside other compounds or salt solutions. Spectroscopy is the way that we can view the light coming off a substance, look at it through a prism, and we can notice lines, and those lines line up to elements. So if we burn a substance and look at their light through a prism, we can discover specific lines that show a different element. And this was used to discover cesium and rubidium. It was also used to discover helium when we looked at light from the sun during a solar eclipse through a prism, and we noticed there was a new element there, helium. Mendeleev, who is the scientist who put forward the periodic table as an idea, he noticed there were gaps in his periodic table, and that allowed scientists to go looking for missing elements. And this was a tool that allowed scientists to start looking for gallium, scandium, and germanium, because you'll see there are some gaps here that predicted the presence of an element that we didn't yet know. Now, there have been many different ideas about the structure of atoms, and for thousands of years, great thinkers have put forward their ideas to explain what matter is made from. Scientists called these ideas models, and they base their models on evidence which is available at the time. Other scientists use new technological devices to test models and to see if they really are the best way to explain ideas. In 1803, John Dalton put forward the idea that the atom looked like a solid sphere. And he was using information from previous thinkers. He did understand that each element is unique, but his model was flawed because he didn't realize that atoms could be split into smaller parts. And you already know about protons, neutrons, and electrons. So this model, whilst the best that it could be in 1803, could be improved upon. Along came J.J. Thomson, and in 1904 he used the cathode ray tube to discover that there were particles smaller than an atom which had negative and positive charges. So using this technological device, he altered the model from being a solid sphere to being what was termed the plum pudding model, where electrons were dispersed throughout a positive background. So this model was great because it included the idea of an electron being negatively charged on the outside, but it was limited because there was still no understanding of what exactly a nucleus was. Then along came Rutherford shortly after in 1911, and he used a technological device of an experiment called the gold foil experiment. And when he fired radiation at a gold foil, he noticed that there was a lot of empty space. And at the center of the empty space, there was a positively charged nucleus. So he changed the model from plum pudding to being a nuclear model, a middle bit with a positive charge, a lot of empty space, and electrons whizzing around. Unfortunately, this model does not explain how the nucleus holds together because there are no neutrons. The next idea that advanced was the introduction of quantum theory, which isn't really a device, it's a technological advance, a way of understanding what was going on, and it was put forward by Niels Bohr just a couple of years later, and he moved into what was called the planetary model of the atom, where the electrons orbit in specific energy levels or shells. We've already met this idea of the first shell holding 2 electrons, the second shell holding 8, the third shell holding 8 as well. And this was a really great advance, and it's actually the one we still use in classroom teaching today. It's very simple to visualize, but it does still have some disadvantages. And they have been addressed to some extent by Schrödinger in 1926, when he used more mathematical equations to explain that actually electrons are found in clouds rather than shells. And this is the best model we have so far for the structure of the atom. It fits all our current evidence, but it's a little bit sort of conceptually difficult to handle in classroom situations, so we refer back to the previous model, the planetary model, when we're talking about atoms at school. So here's a poster that summarizes all of that. Pause the video and have a closer look and a closer read of the progression of ideas about the history of the atom.